So hello everyone, welcome to another particular reagent chemistry lecture series. So this is our class 5, and in this particular lecture we are talking about the other NaBH4 derivative. So in our class 3 and class 4 we are mainly focused on the NaBH4 and Luce reagent. We have done an elaborative discussion over NaBH4 and Luce reagent. So if you missed that particular lecture, then I will highly suggest to first go through class 3, class 4 and then come back to class 5, because this is the continuation class. So here in this particular class, we are mainly focused on the uh, other NaBH4 derivatives such as sodium cyanobohydride and NaBH4 NaBH3 OAC or NaBH OAC whole thrice. So before starting our initial discussion, let us talk about a little bit of stereochemistry of NaBH4 reduction. So since NaBH4 is a small reagent, so it will attack from the both side, like from the upward direction and the downward direction. However, the majority will decide on the steric factors. Like here you can see that this is the cyclobutane type of structure. Okay, so in presence of NaBH4, since this particular methyl in the above direction, so as you know that this particular cyclobutane are present in this type of Packard formation. So I have discussed everything about the dynamic stereochemistry of conformers in our conformational playlist. So if you don't know about this, then I will highly suggest you to visit that particular lectures also, where I will show this type of geometry or type of conformational stability in the 3D space. So you have to go there. So here you can see that there is a two possible pathway of any hydrate to attack. Like one pathway is here and one pathway is here. Now in the hydrate can attack from the both pathway. If hydrate attack from this particular pathway, then the OH become in the dash bond and the hydrate become the wedge bond. And if the hydrate attack from the lower region, then hydrate become in the dashed bond and the OH become in the wedge bond. Now this both the structure is observed, but this type of this structure is a major, because here if the reagent approach from this particular center, you can find there is a diaxial interaction observe, or the particular hydrate will face the diaxial interaction, and that's why the other product become minor product, whereas the hydrate attack from the lower side will generate the major product of the particular reaction. Similarly, in the case of cyclopentanone type of structure, like as you already know, I hope that the cyclopentanone will stay in the open envelope form. So here you can find here that here if the hydrate goes from this particular site, then what happened that it will face interaction or the steric hindrance due to this particular methyl group, and that's why this particular hydrate will prefer to attack from the upper side to keep this particular OH in the lower region. So what happened that this particular hydrate is present in the wedge bond, where the OH present in the dashed bond. So that's how we will determine the geometry of the particular product while reduction NaBH4. Now let us talk about the NaBH OAC whole thrice. So how to prepare this particular reagent? Like simply you will add NaBH4 and the acetic acid will react to generate this type of reagent. Now if we look about this particular reagent, it is bulky because of this particular addition of this particular SCO part. The reagent become bulky, and since it is a bulky reagent, now the stereo selectivity getting increased. Like in the case of previous part, as we already discussed, that NaBH4 is small reagent, so it will attack in the both of the cases. So maybe it happened that this particular product as well as their minor product will have 60-40 ratio. But if we want to increase the yield of this particular this particular product more, then we can increase the bulkiness of this particular reagent, and thus actually done by the NaBH OSA whole thrice. It actually increase the bulkiness, and with this, when this particular attack here, so it will more and more attack from the lower hand side to eliminate the steric hindrance. So gradually the yield of this particular is increasing. So and thus the selectivity getting increased. And but since it is a selectivity is increased, but it is a less reactive reagent, so the chemoselectivity is also changed here. So this particular reagent is only limited to imines and iminium ion and aldehyde group reduction. Ketone are not reduction in normal condition by using this NaBH OSC whole thrice. Okay, and it's a mild reaction condition, room temperature the reaction happen, and offer high selectivity for reductive amination. Okay, and reductive amination is nothing but this. So basically what happened, that this is our iminium ion. So it is a formation, how to form the iminium ion, you can see here. And after formation of iminium ion, then NaHbOSC whole thrice will attack here, the hydride will attack here to form this type of compound, and this is the a compound of reductive amination. Okay, now let us talk about the another NaBH4 derivatives. It is sodium cyanoborohydride. It is a very important reagent because this reagent is a pH dependent reagent, NaBH4. It is also milder than NaBH4 at pH 7, and it is a highly pH dependent reagent. That is the very selling point of this particular reagent. Like this particular reagent is the pH dependent, and it actually tolerates the acidic condition, where actually in NaBH4 the acidic condition is not tolerable sometimes, because there is some kind of starting material is there which actually contains an acid tolerative functional group, and to that tolerate the acid tolerance functional group is there, then NaBH cyanoborohydride is used for that particular reactions. And it also shows the chemoselectivity in different pH condition, like at pH 4, less than 4, in the highly acidic condition it readily reduces aldehyde and ketone, but in the basic condition when the pH is greater than 7, then it is reduced iminium ions only, but the carbonyl groups is not getting reduced at higher pH condition, or we can say that in the basic condition. And this is the most selling point of this sodium cyanoborohydride mediated reaction. So here you can see here that in aldehyde or ketone, in presence of sodium borohydride at acidic condition, it generate the um, corresponding alcohol, but in the higher pH condition no reaction has been observed. It is very important. And herein also you can find that this react with NH3 to generate the iminium ion, and after that the sodium cyanoborohydride will donate the hydride here to form this type of uh, amine group, and this is actually happening in the higher pH condition. But in the higher pH condition, this particular aldehyde or ketone or the carbonyl groups not getting reduced by using sodium cyanoborohydride. And also sodium cyanoborohydride shows some different reactions. Like first we can say the reductive amination. Here is also, it is a nothing but a reductive amination reaction, this particular, where the iminium ion is initially generated, and after that by treating with sodium cyanoborohydride we got this particular amine group. So the reductive amination takes place by using this type of sodium cyanoborohydride. Also sodium cyanoborohydride is used SN2 reaction. Like here you can say there is a carbonyl group is there, and also there is a leaving group is there. Since we know that in neutral condition or the basic condition, sodium cyanoborohydride doesn't react with the carbonyl compound, so this particular hydride will actually perform a SN2 reaction here, and this particular OTS, that is a good leaving group, is actually leaving from the particular reaction starting material, and we got this type of product with keeping our carbonyl group intact. Okay, and also it will show the carbonyl group reduction in the lower pH condition or acidic condition. It will reduce the carbonyl group to their corresponding alcohols. So this type of reduction has been shown by sodium cyanoborohydride, and it is a highly pH sensitive reagent. So with this we have to end this particular lecture, and we already end with our sodium borohydride and derivatives part. In the next class onwards, we are talking about the lithium borohydride and selectrides and the other nucleophilic reducing reagents. So thank you for listening. We'll meet on next class.